Hi, good afternoon, everyone. I'm Sutapa Bansal, Director of Product Management at Mirantis. Very excited to be with you all here and with a set of very esteemed panelists. So today in this session, we are going to talk about network function virtualization. And let's start by introducing our panelists. So let's start with Chris Price, who was the TSC chair of OPNFV and actually needs no introduction, but I'll give you a minute. Please go ahead.
So I'm Chris Price. I work with the OPNFV group. For those that don't know it, it's really a collection of interested parties who want to put together an NFV-centric platform, looking at how we bridge the gap between what we think of as traditional cloud and how we bring that to the network domain. I work for Ericsson, and of course, we have a very large interest in modernization of mobile networks, how we go from 4G to 5G, and how we bring NFV along with us.
Thank you. Valentina?
Hello, everyone. My name is Valentina Ilaria. I work for PLUMgrid. We're a software-defined networking company. I've been working with customers deploying OpenStack and leveraging SDN and NFV solutions for many, many years, since the early days of OpenStack. So I have a lot of experience with rolling this technology into production environments and bringing the agility and orchestration of, of the cloud platform to the network paradigm.
Thank you. Andrew, he leads the infrastructure team at Comcast and is representing the entire service provider industry here. Andrew?
Thank you. Yes, so we run an internal private cloud at Comcast. We support over 600 different internal customers, many of which are virtual network functions. And being a network company, we start to push those limits at scale in supporting, our millions of internet customers and cable customers.
Thank you. Ronen, who leads entire product management and Mirantis and has great industry experience. Ronen?
So hi, everybody. I'm Ronin Hoffman. I'm a VP of Product at Mirantis. And I'm working on a day-to-day basis with a lot of telcos and providers of NFV solutions to see how we bring it to the market quickly.
Thank you. So from a context perspective, network function virtualization enables telco appliances such as Evolved Packet Core, IMS, and many others, as well as traditional virtual appliances like firewall, load balancer, DNS, and others to be virtualized and provisioned on standardized industry hardware. Many providers also say that it enables and eases the way they are managed and orchestrated. We are seeing many POCs as well as some deployments, but we have not seen widespread adoption of NFV, and there are many unanswered questions. So that's what we want to address in this panel today. Let's start by looking at what are the key use cases. So we hear many use cases, virtual CPE and others, but Chris and others, can you please share what are the key use cases in your mind for NFV and what are the benefits of NFV?
I'm actually going to punt this down to an operator who's dealing with it. Let's kick it off. Let's have Andrew start with that one.
Andrew.
Yeah. So two of the key use cases we're looking at is for our commercial customers, virtualizing the CPE as well as virtualizing our provider edge, and allowing by deploying OpenStack down at the edges of our infrastructure, being able to run multiple workloads there and be flexible based on customer needs versus deploying dedicated appliances that don't give us that flexibility. So we may have one customer that wants virtual CPE, wants a virtual provider edge, and then we can service chain in a firewall or whatever other services, IDS, et cetera, all within that same platform instead of having to deploy multiple platforms to support those workloads.
Great, thank you. Ron, would you like to add to that?
Yes, so when you talk about NFV, there are all these three-letter acronyms that everybody in the circle knows about and nobody else does. So we see two types of NFV use cases broadly. One is the telco style, the EPCs, the IMS, those things. And we see the more enterprise user. Everybody needs a firewall and everybody needs a router. And there is some overlap. So when we talk about NFV, we really need to be very clear about what is the use case. And one of the things we do when you come to a customer and say, well, I want to do some NFV, like, okay, let's focus on the first use case. What are the first use case? Most of the time, it's a virtual router, virtual firewalls. And when we talk to folks like the carriers or Ericsson or others, we hear more about the other side of the house. So I think broadly we see those two. On the telco side, as you said, virtual EPC, we see it a lot. We see SBC, we see IMS. We see those as the leading use case that everybody are looking at. And so that is the different categories and different leading use cases we see right now.
Thank you. Valentina, I'd like to add to that.
Yeah, I think, really to the point, there's these two classes of use cases, and it really boils down to the ability to define the service chaining. So what the network looks like for the application or the user that you want to deploy on a generic cloud. It doesn't have to be an NFV cloud, right? It's really how to map this user need on top of, for example, an OpenStack environment and being able to easily and on demand define what the network looks like, so what the sequence of services look like, and then orchestrate the instantiation of these services, whether it's through virtual appliances or through a distributed kind of infrastructure.
Sure. Thank you. And Andrew, would you be able to share that from a Comcast perspective and from others that you're seeing in the industry, what is the real state of NFV? Are you actually looking at deploying applications, and what kind of applications, or still it's at a hype cycle, still at a POC stage? Can you talk more about that?
Sure. So I think it actually goes to Ronin's point a little bit in terms of which use cases are you talking about. So,
right.
I mean, I will say that we actually have a high number of NFV apps running in production at Comcast today. Mm-hmm. They are running on top of OpenStack. We're not necessarily orchestrating them or using service chaining that does anything other than hosting that right now today on top of it. We are taking advantage of the fact that we have APIs to deploy and whatnot. But they are running on top of OpenStack today, and they are serving production use cases at Comcast scale. And we're doing that for both enterprise, so we have some of our internal voice systems and whatnot running on top of OpenStack today, serving our enterprise use cases, and that would be typical of any enterprise, not necessarily a service provider. And we have service provider use cases in that, and so we've been working with our apps like DNS and other things like that to onboard on top of it. Where we are starting to push the edge is in the service provider category, and that's where we're doing more proof of concepts. They're working. The question is how do we do it efficiently? How do we do it at scale? I think there are others that are doing, from what we hear, production earlier than we are, so we are not necessarily the cutting edge. So I think OpenStack can do those things. It's just we are starting to explore, and one of the challenges we were talking about earlier is we want to do those things on a general purpose cloud. We are not building out a dedicated network cloud to support these use cases. And so the challenge is how do we run a service provider level network function, a virtual network function next to a web app and next to a video app and all these different type of apps, and that they coexist and are being able to manage on the same platform, whether instead of separate platforms.
So to follow on to that, is it the challenge is more around performance of these VNFs in that integrated cloud environment, or there are other factors to that?
So I think there's two challenges. One, to your point of service chaining, like what is the platform that we're going to leverage for service chaining? And I think we have a preference that that be an open platform, and how can we invest in those ecosystems? And I think the other one, yes, is performance. And doing performance while coexisting with other apps that have different requirements, maybe around security or in other spaces, and having them peacefully coexist. And yes, we could segregate out hypervisors, but then anytime you start to segregate out infrastructure, you're losing some of the benefits of cloud. So how do we architect an environment that supports all those use cases at the same time?
Yeah, of course, you'll get into challenges like that if you're looking at SRIOV or DPDK, because
and security groups
yes.
at the same time. Yeah.
Yeah. So I think we definitely need far more innovation happening in the area to make it real for all classes of these VNFs. Yes. Anyone else would like to comment on that?
I think it's maybe not just a matter of more innovation. I think there's plenty probably innovation at this point, but it's a matter of creating some common ground across all of us, and creating a common definition of what NFV is. I would claim that maybe there's more deployments of NFV than we think there are, because there is customers that have production deployments where they actually bring up isolated environments where they service chain VNFs and they get offer on demand. Maybe they don't call their deployment an NFV deployment, but they actually get the same benefit and they solve the same the same use cases. So creating a common vocabulary and a common set of tools that can be used to then go and solve these use cases. I think there's plenty of innovation. It's just how to get consumed. Customers can get overwhelmed by too much.
Definitely, definitely. Okay, and now let's switch gears a little bit and talk about OPNFV, which is an open source project aimed at fueling a reference architecture for NFV. And let's start with Chris, who is actually the TSC chair right now for OPNFV. So can you share your thoughts about OPNFV and what are the key projects where you see which are leading to growth of adoption of NFV and making it more real?
Sure. So as I mentioned, OPNFV is a community that's come together to try and address the NFV challenge together and try and find some of those common vehicles that we're all looking for. We're focused specifically on open source technologies. We're trying to avoid choosing winners, if you like. And to the point of when does NFV happen and how does NFV happen, I think what we, working for a vendor of networking equipment, we've been vending a lot of equipment in virtual environments for many, many years. It's not something new. I think the challenge that we're trying to address with OPNFV is to look at some of the broader scale, let's say company-wide type of, country-wide type of deployments where you might have mobile edge computing, you might have packet edge computing from mobile devices, and we need to be able to move these into a virtual environment. When you try and address those challenges, you find that it just doesn't really fit, right? You're trying to put something that wasn't built for that environment into that environment. The environment itself wasn't expecting that kind of workload. Right. And so we look at, what do we need to do in an OpenStack context in order to accommodate the types of use cases, the types of traffic, the types of service chaining that we require in order to be able to get the traffic through such a complex infrastructure. And in OPNFV, I think if we look at some of the projects, of course we have the deployment projects to actually get that out there. We have a Pharos activity, and Pharos for us is a global lab environment. So we have labs established around the globe, and we tie all of those together into one CI/CD pipeline. So we're able to deploy our platform to any of those locations. And then we do things like vSwitch performance. We do consistent testing of vSwitch performance on different hardwares with different deployment types. We have, in addition to those, we have projects which focus on making improvements in those. So we have a team focused on developing OVS improvements and upstreaming those. And similarly with OpenStack around management and performance metrics and these types of things, we have projects focused on those types of activities as well. An area of interest for us really is in the networking space and SDN, and we have a lot of SDN controllers participating in the project, and what we're trying to do is try and normalize how we can model the capabilities that those SDN controllers and infrastructures bring and create a consistent way for an application to deploy on top of any one of those.
Sure. Yeah, I think this is really some of the key areas where, like in the Arno release, we made good progress where you're actually able to deploy the infrastructure and all these other projects, like 30 projects that are there. They are definitely paving the way so that like when we have the Brahmaputra release coming up, it's far more cohesive and efficient.
We hope so.
Is any of you or your company part of the OPNFV projects, and can you share if you're making any contributions there?
So I think when you look at OPNFV, it's actually, the way we look at it, it's a framework, and where OpenStack is just part of it. Important part, but a part of it. And what we're trying to think all day long is how we are making OpenStack as robust underlying infrastructure for the NFVI Vim layer for NFV. And those used to be like a dedicated machine with triple, quadruple redundancy, and this OpenStack doesn't work that way. And for us to move to NFV, there needs to be a lot of changes made first to this underlying infrastructure to harden it, to make it more secure, more highly available. But there needs to be a lot of thinking going into the functions themselves. They cannot rely on a completely redundant and fault-tolerant hardware anymore. And this is, I think, a big paradigm shift that is going on as part of just taking a firewall and making it like virtual firewall. It's like now you have to think about how you make sure that it is highly available, it has the performance it used to have. And part of the thought process that we're in is how do we make this baseline, this underlying infrastructure, which is OpenStack, first of all, performant, that it will perform as it used to be, available and secure. So, and those are generic things that we have to take care of. You know, as long, on top of that, you have to make sure it's upgradable, patchable, and lifecycle managers handle. So, in order for OPNFV to succeed and for us to have a real NFV solution, we need to figure out all the different pieces in the puzzle and work them separately. I think that is the main focus that a group like Mirantis is focusing on.
Yeah, thanks. And I think this ties in very well with what Chris was suggesting earlier, that the kind of applications that we are moving to a cloud OpenStack infrastructure, they have been there for a very long time, and they were not designed initially to run in this kind of an environment. And now we are not simply taking those applications and virtualizing them and think that they will give the same kind of performance when the underlying infrastructure was not designed for those set of applications, and how we can, you know, marry the advantages of both of them and bring them together. Yeah. Sure. With that, I'll also like to invite Kyle McDonald on stage. So he is an advisor to Big Switch, and he would like to talk about a real use case deployment of NFV. Thanks.
There we go. Yeah, so we wanted to talk a little bit about a large deployment we're doing with one of the largest phone companies here in the United States. It's something we actually sealed up yesterday, finally, so we're excited to announce that over the last 6 months, we've built one of the largest OpenStacks that I know of in the fastest time I've ever heard of, going from 4 to 50 pods by the end of this next 6 months. And it will be holding NFV traffic for one of the largest NFV applications we know of in the world, including things like handset backup, EPC, a mobile transcoding application, and some others. So when the question came up earlier today to me whether OpenStack and NFV was a real thing and whether we were actually seeing it in production, I was excited to come up here and actually talk about something happening in real time today. So there you go.
Thank you. Thanks, Kyle. I'd also like to open up for Q&A. We have a couple of minutes, so if anybody in the audience would like to ask a question.
There's one down the front.
Is he? Okay, please. Yes, please.
I'm somewhat new to this area. I just wanted to understand the difference between NFV and SDN. I mean, Google's got OpenFig, and there's all these things going on. NetConf, vendors support them. Maybe there's a whole host of questions that I'm asking. How much is NFV being supported by the vendors? How is it compared to the other technologies?
Sure. So I'll try to address a little bit, and also, you know, I invite Valentina to add to that from a SDN perspective. So essentially, network function virtualization, it is, I would say, a broader technology compared to SDN. The whole idea with NFV is that we talked about, you know, various two classes of applications, which could be traditional service provider applications, simply running your voice services, which when you used to buy integrated hardware and software from, of course, vendors like Ericsson, Alcatel, Lucent, and many others. And now, instead of that, what is happening is there's a disaggregation happening where you can buy standardized hardware from vendors and put many of these applications on top of that. That's the whole concept with network function virtualization, right? And the notion with SDN is, which is, how do you ensure, like within OpenStack, you have Neutron as the networking layer. and it offers many basic layer 2 and layer 3 capabilities, but SDN offers far more advanced networking functions on top of that. So it is, of course, a layer, a very important layer for things such as service chaining, for wide area network connectivity, which are important for network function virtualization to become real and its adoption. Right, and Valentina, please add to that.
I think the way to look at SDN is that it really transforms how networking gets delivered and deployed, right? So it's this software model. You can orchestrate it. You can create it on demand. And then NFV is kind of one possible application of leveraging SDN, but there's many other use cases. There are other verticals that can be built on top of it. So look at SDN as the transformation of the networking layer, how it gets delivered in software, how it gets distributed inside, for example, the hypervisor layer, the compute node, right? And then NFV as a consumption and a much broader set of technologies, right? As part of, for example, OPNFV, all the other layers of the stack that are addressed as part of it.
I think if I can add, I mean, you talked a little bit about things like OpenConfig. And when you address the question from an NFV perspective, you're going to be needing to use things like OpenConfig in order to address the broader parts of the network than that which is in your control, if you like. So you have the SDN capabilities that enable you to accelerate, how you're distributing traffic within the context of a tenant, and then you're using things like OpenConfig to address the broader parts of the network. And we try and, from an NFV perspective, wrap that up into something which is communicable and understandable and utilizable from an operator's perspective, I guess.
Great, thank you. Thanks, Chris. Yes, please.
So I got a quick question. What do you see changing to allow some of these technologies in NFV that require a lot of bandwidth, things like virtual firewalls, things like virtual routers? What do you see changing to allow higher throughput and more density?
Sure. Go ahead, please.
So I think what needs to change is, the perception of what a firewall is and how do you distribute it among more than one, maybe physical device. How do you scale out? Because the whole thing about cloud computing is the ability to scale out now. And I think NFV naturally is a scale up, narrow, one point. And this is a point of contention because when you have one box, you have a lot of functions, the bandwidth is physically limited. And then you've got things like SROV, DPDK, or just put a lot of ports into it. But I think there needs to be a fundamental mindset shift in how do you create a virtual network function which can scale out in a very efficient way. And right now people are saying, okay, I got this firewall, they're calling the same name, put in software and put it here. That may not fly, in the long run. We'll have to see. So that's just my kind of read on what I see in the field there.
Yeah. Do you like to add?
I absolutely agree. I think NFV usually translates into a virtual appliance, and that's not necessarily what is going to get us to the performance scale out that we need for large-scale production environments. So a through transformation of what layer delivers this function, and in my opinion, it has to be in every compute node. It has to be fully distributed. It has to be able to auto-scale so that those functions can live anywhere. It cannot be dedicated nodes that perform these network functionalities, because then it's a nightmare to size, from a performance perspective, high availability, and all of it. So truly, a layer that it exists everywhere that can give these functions on demand.
Thank you. Do we have, yes, please?
I'm going to be slightly controversial here. You look at an application like, say, Netflix, which is television application. It's big, it's growing. They built that on top of ordinary, boring, non-SDN, non-NFV clouds and infrastructure. What is the real use cases that is driving wanting to put more and more intelligence into the network layer? What are we saying we can't build unless we have NFV, unless we have SDN?
Andrew, would you like to take that, or I can take that?
So, I mean, I think it's actually a very interesting question. I mean, today we actually have a pretty simple infrastructure deployed. We are, we use basically stock neutron and OVS, and we are not doing any kind of what you might traditionally call advanced SDN. I think where we look to SDN is for, as we scale out our platform and grow, can we get more efficiency out of what we're deploying? Can we get better operational flexibility, like being able to shift traffic around, things like that? So it's not necessarily that it prevents us from being able to do those things, but that it enables us to do it more efficiently, at better cost, be able to react to situations better. That type of flexibility might be a win for us in the long run, and that's why we explore, what is our next generation networking platform going to look like? If we need to be able to distribute some of those network functions and be able to account for traffic shifts, right? Giving us that flexibility to turn off something here, pull up something here, tunnel something there, that can enable us to say, okay, well, we lost this data center here. Now we can distribute that data center's traffic across 10 other data centers, right? So, the question is, do you do it in the infrastructure layer? Do you do it at the application layer? I mean, Netflix addresses a lot of it from the application layer, and that might work depending on your environment, right? But there might also be advantages in being able to do it lower in the stack. So I think that's kind of the tension that needs to still be sorted out.
And it's also, where are you putting the intelligence? Is it like Netflix, they are known to run Chaos Monkey and all. The whole paradigm is that the application itself is which provides this resiliency. It's not expecting that from the underlying infrastructure layer, right? But many of the applications that are existing today, that may be legacy applications, which are trying to move to this new infrastructure, need to coexist with the cloud-native applications. I think, and that is the challenge OpenStack is trying to address by stating that, yes, there will always be, legacy applications, but then, of course, we need to adopt to the new set of cloud-native applications.
I might even add, so there's a lot of good lessons we can take from Netflix about how to build an application that runs in the cloud. But if you look at how Netflix works today, it expects there to be a network. You can't watch a Netflix movie unless you have a mobile phone connected through a lot of existing physical infrastructure. And NFV is not so much about trying to fix Netflix or trying to fix the model that Netflix has. NFV is more about trying to bring that infrastructure that those types of functions are dependent on and move them into a cloud-like behavior as well. And when you look at the models that you need to support those types of network infrastructures, like I said, Netflix gives a lot of good lessons, but it doesn't necessarily address the aggregation of 200,000 particular endpoints coming into a certain domain where decisions need to be taken on an aggregate fashion to then provide that upstream towards something like Netflix. It's a slightly different model and a slightly different usage domain. And like I say, lots of good things to bring from those types of learnings into what we're trying to do with the existing infrastructure that currently exists in a point-to-point fashion rather than as a virtual device.
Okay, and I think we are good on time. So thanks a lot for participating. And again, a round of applause. And thanks for all the panelists. Thanks.
Okay. Thank you.